Imagine, you're an astronaut, the first human to step foot on a newly discovered planet. You gaze up at the alien sky, two moons hanging low on the horizon. You reach out to touch this strange bioluminescent plant, and then you hear it. A low hum, a rhythmic pulse, a melody unlike anything you've ever heard on Earth. That's the kind of experience we're exploring today, the sounds of the universe.
It's a captivating thought, isn't it? That even in the vast emptiness of space, there's a symphony of sound waiting to be heard. And what's fascinating is that we don't need to travel to distant planets to experience this. Even our own planet has a unique sonic signature.
Welcome to Cosmos in a Pod, the Space and Astronomy series. Please like, comment, share, and subscribe. That's right, we often think of space as silent, but it's anything but. So let's start with Earth. If we could listen to our planets from space, what would we hear?
Well, one of the most prominent sounds would be the eerie chorus of what are known as Whistler mode waves. These are electromagnetic waves generated by lightning strikes.
Wait, so lightning on Earth creates sound in space. How does that work?
It's a bit like dropping a pebble in a pond. The lightning strike creates a disturbance, a ripple of energy that travels outwards. But instead of water, these ripples travel through the plasma surrounding our planet.
Plasma. I remember learning about that in science class. I need a refresher. What exactly is plasma, and how does it carry sound?
Think of it this way. You have solid ice, then liquid water, then gaseous steam. Plasma is like the next level of matter where atoms are stripped of some of their electrons. This creates a sea of charged particles that can be influenced by electric and magnetic fields generating waves that we can translate into sound.
Okay, that makes sense. So the lightning strikes create these waves in the plasma surrounding Earth, and that's what creates the Whistler sound.
Precisely. And these whistlers aren't just random noise, they actually reveal a lot about the structure and dynamics of Earth's magnetic field, which acts as a shield protecting us from harmful solar radiation.
So by listening to these sounds, we can learn more about how our planet interacts with the space environment. That's pretty cool. Are there any other Earth sounds we can pick up from space?
Oh, definitely. There are also chorus waves, which sound like a chorus of birds chirping, and hiss waves, which resemble radio static. These are caused by interactions between charged particles from the sun and Earth's magnetosphere.
So our planet is quite the noisy neighbor in space.
It is, and it's a reminder that even seemingly empty space is teeming with activity, with energy constantly flowing and transforming.
Now, I'm curious about the big guy in our solar system, the sun. I know it's a giant ball of burning gas, but can it make sounds too?
It certainly can. Imagine the roar of a nuclear furnace amplified to an unimaginable scale. That's the kind of sound the sun produces.
Whoa. But if it's gas, how does it vibrate to create sound?
Remember, sound is just vibration traveling through a medium. And the sun's outer atmosphere, the corona, is actually made of superheated plasma, just like the plasma surrounding Earth. This plasma is constantly churning and swirling, creating waves that we can detect and translate into sound.
So we can actually listen to the sun's plasma waves. What do they sound like?
It's a truly awe-inspiring sound. A symphony of crackling energy, deep rumbles, and even explosive bursts caused by solar flares. It's a reminder of the immense power of our star and the constant dance of energy happening at its core.
This is blowing my mind. It really changes the way I picture the sun. It's not just a silent ball of light. It's this dynamic and powerful being with its own unique voice.
Exactly. And what's even more remarkable is that we can use these sounds to study the sun's activity, to understand how solar flares erupt, and even to predict space weather that could affect Earth.
So, by listening to the sun, we can learn more about how it impacts our own planet.
Absolutely. And we can also gain insights into the fundamental processes happening within stars, not just our own sun, but stars throughout the universe.
Wow, this is incredible. We've gone from eerie whispers around Earth to the thunderous roar of the sun. And I bet there are even more amazing sounds waiting for us as we venture further out into the cosmos.
You're absolutely right. Next, we'll journey beyond our solar system to the strange sounds of distant planets and the rhythmic beats of pulsars.
I can't wait. This is getting really exciting.
Each planet in our solar system, with its unique composition and atmosphere, creates a distinct soundscape. Let's start with a place that's always intrigued me, Venus.
Ah, Venus. Our sister planet, shrouded in thick clouds. I've always pictured it as a scorching hot volcanic world. But what would it sound like to stand on its surface?
Well, the first thing you'd notice is how loud everything would be. Venus's atmosphere is incredibly dense, about 90 times denser than Earth's. This means that sound waves travel much faster and lose less energy as they propagate.
So every sound would be amplified, like
Huh.
turning up the volume on a speaker.
Precisely. But it wouldn't just be louder, the pitch would also be affected. The higher density of Venus's atmosphere would cause sounds to have a lower pitch, making them deeper and more resonant.
Interesting. So imagine a deep, booming voice echoing across the Venusian landscape. But I also remember reading that Venus's atmosphere is mostly carbon dioxide. Wouldn't that affect the sound as well?
You're right. Carbon dioxide is a heavier molecule than the nitrogen and oxygen that dominate Earth's atmosphere. This means that higher pitched sounds would be absorbed more readily, further contributing to the deep, bass-heavy soundscape.
So listening to Venus would be like experiencing the world through a subwoofer. It's almost like each planet has its own musical genre. What about Mars? What would it sound like to stand on the red planet?
Mars, on the other hand, is almost the opposite of Venus. Its atmosphere is incredibly thin, about 100 times thinner than Earth's. This means sounds would be significantly fainter and travel much slower.
So it would be a world of whispers and echoes.
Exactly. And because Mars's atmosphere is also mostly carbon dioxide, those faint sounds would be dominated by low-frequency rumbles, almost like a distant heartbeat.
It's fascinating how these seemingly simple facts about atmospheric composition can create such vastly different sound experiences.
It really highlights the interplay between physics and perception. Imagine the challenges faced by future explorers trying to communicate in such alien environments.
I hadn't even thought of that. It would definitely make things more complicated. Now, I'm curious about the gas giants, Jupiter and Saturn. Those planets are enormous. What kind of sonic mayhem do you think they create?
The gas giants are a whole other category of soundscape. Jupiter, for instance, is known for its colossal storms, like the Great Red Spot, which has
Right.
been raging for centuries.
Oh, I've seen pictures of the Great Red Spot. It's this giant swirling vortex bigger than Earth. What kind of sound do you think a storm like that would produce?
Imagine the most powerful hurricane you can think of, then multiply it by 1,000. The winds on Jupiter can reach speeds of over 400 miles per hour, generating intense pressure waves and shock waves that would create a cacophony of deep roars, hisses, and whistles.
That sounds absolutely terrifying. It's like standing inside a giant cosmic jet engine. And what about Saturn? Does it have similar soundscapes?
Saturn's sounds are equally impressive, but with a unique twist. Remember Saturn's rings? They're not just a beautiful visual spectacle, they also create a fascinating acoustic environment.
Wait, the wings make noise. How is that possible?
It's all about resonance and vibration. The particles in Saturn's rings, mostly ice and rock, constantly collide with each other. This creates a subtle but persistent hum that can be detected by spacecraft passing through the ring plane.
So the rings are like a giant cosmic wind chime. That's an image I won't soon forget. It's incredible how each planet has its own unique acoustic signature shaped by its atmosphere, its weather patterns, and even its rings.
It really shows how diverse and complex our solar system is. And we've only scratched the surface. There's a whole universe of sound waiting to be discovered beyond our planetary neighborhood.
And speaking of cosmic dances, I'm curious about objects beyond our solar system. What about the sounds of distant stars and galaxies? Can we even hear those?
We can, and some of the most fascinating sounds come from a type of star called a pulsar. These are incredibly dense, rapidly spinning remnants of collapsed stars.
I've heard of pulsars. They're like cosmic lighthouses, right? Emitting beams of radiation that sweep across space.
Exactly. And when those beams sweep past Earth, we detect them as pulses of radio waves. Now, here's where it gets really interesting. Scientists can take those radio pulses and convert them into sound.
Wait, so we can listen to the rhythm of a spinning dead star? That's incredible. What does it sound like?
It depends on the pulsar. Some pulsars spin incredibly fast, hundreds of times per second, creating a high-pitched whirring sound, almost like a cosmic drill.
Wow, I can't even imagine a star spinning that fast. Are there slower pulsars too?
Oh, yes. Some pulsars rotate more slowly, maybe once every few seconds. These create a deep, rhythmic pulse, like a cosmic heartbeat.
It's amazing to think that these seemingly silent objects are actually producing such a wide range of sounds. It's like they're broadcasting their own unique code across the universe.
And by studying these sounds, these pulsar songs, we can learn about the physics of these extreme objects, how they formed, and how they evolve over time.
So it's not just about the sound itself, it's about the information it carries, the secrets it reveals. Now I have to ask about the ultimate cosmic mystery. Black holes. Can we hear the sounds of black holes?
That's a great question, and it leads us to one of the most groundbreaking discoveries in modern astronomy, gravitational waves.
I've heard of gravitational waves,
Yeah.
but I'll admit I don't fully understand them. How can we hear something that's essentially a ripple in space-time?
It's a bit mind-bending, but essentially when massive objects like black holes collide, they create these ripples in the fabric of space-time. These ripples travel outward at the speed of light, carrying energy and information about the event that created them.
Yeah, I'm starting to follow. But how do we detect these ripples? And how do they translate into sound?
We have incredible instruments like LIGO, the Laser Interferometer Gravitational Wave Observatory, which can detect these incredibly subtle distortions in space-time. And when those signals are processed and converted into sound, they create a distinctive chirp sound.
A chirp. So the collision of two black holes, these incredibly massive and powerful objects, sounds like a bird.
It's not exactly a bird song, but it does have a rising pitch that resembles a chirp. It's a haunting and awe-inspiring sound, a testament to the immense power of these cosmic events.
That's just incredible. It's like listening to the universe itself, to the echoes of these cataclysmic events that shape the cosmos. And it makes me wonder, what else is out there? What other sounds are waiting to be discovered?
That's the beauty of science and exploration. There's always more to learn, more to hear, more to discover. And with every new instrument, every new technique, we're opening our ears to a universe that's far richer and more complex than we ever imagined.
Well said. This whole deep dive has been a revelation. It's changed the way I think about space forever. It's not just a silent void, it's a vibrant and dynamic symphony of sound.
I'm glad to hear that. That's the power of curiosity and imagination. Keep looking up, keep listening, and you'll never cease to be amazed by the wonders of the universe.
On that note, I want to thank you, our listeners, for joining us on this sonic adventure through the cosmos.
And don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel for more explorations of the universe.
Until next time, keep exploring and keep listening. The universe is full of wonders waiting to be heard.